Okay, so this very last part is about common logarithms and natural logarithms. The base 10 logarithm, log base 10 of x, is called the common logarithm, and it is written as log of x, where the base 10 is implied. So we do not write the 10. So log base 10 of x is the same as log of x. These are the exact same things. So if you ever see a log written without a base, it means it's a base 10. Similarly, the base e, log base e of x, is called the natural logarithm and is written, we give a special notation as ln of x, which means the natural logarithm of x. The number e, just recall, is 2.718 and so on. So what this second part says is log base e of x is ln x. So it's the natural log of x. The next part, so this example 4 has to do only with common logarithms and natural logarithms. So log of 900, and the nice thing is your calculators by default use the log base 10. So you could just plug these into your calculator and get a value. So log base 10 of 900 would be approximately 2.9542. And you could round that to 2.95 if you would want to. So that would be the log of 900. You just plug that in your calculator, you type log 900, and it'll give you 2.9542. And just so you can see how it's plugged into the calculator, so you would, you're going to want to add to calculator, and you would type where it says log, hit control, and it's 10 to the power of x. So log base 10 of 900 is 2.95, whoops, sorry, you can't see that. 2.9542. The next one, ln e, so you would hit control and then e to the power of x, and ln, and then we'll type e. So control, not control, we'll hit e to the first power. And that gives you 1. So this equals 1. So you just use a calculator for these. ln of negative 1.87, well, you can't have a negative result, as we said earlier. So if we plug this in ln negative 1.87, you would get something that is undefined. So it says non-real calculation. So we would say undefined. So you cannot take the natural logarithm of a negative number. The next part of this, so that's how you compute common logs and natural logs. You just plug these things into your calculator, where the base is 10. And for ln, you don't have to worry about a base because the base is e. So this then takes us to solving equations with logarithms and exponents. Sort of a couple steps that I would use. The first one is to identify the base. So what is your b? And then use the base and the fact that logarithms and exponents are inverse. So for any base b, such that b is bigger than 0 and b is not equal to 1, these following two statements are true. Log base b of b to the x equals x. So what this says is, here's an example, log base 3 of 3 squared, log base 3 and the result of 3, these would cancel, and this would just become 2. So if your base and your result are the same, then your answer is just whatever your power is. Similarly, b raised to the log base b of x power equals x. So here's an example of that one. Log, oops, we don't want that. We want, let's say, 4 to the log base 4 of 5 again, the 4 and the log of 4 cancel, and this would just become 5. So if in this case, if your base and your result are the same, they cancel and your answer is the exponent. So 3 squared, so your answer would be the 2. Similarly, here your 4's cancel and you're left with 5. So we're going to use this fact, these few facts, to help us solve the following equations. For example 5, to solve the equation, 25 equals 10 to the x minus 1. X minus 1 is in the exponent. So if I take the logarithm of both sides, so if I take the logarithm of 25 and I set that equal to the logarithm 10 to the x minus 1, and recall, this implies if there's no number there, it implies it's the log base 10. So log of 25 is just going to say log of 25. This is log base 10 of 10 to the x minus 1. Well, if we look at part A, then we'd realize that, hey, I have a base 10 and I have a 10. Those cancel. So this is log of 25 equals x minus 1. So to solve this for x, add 1 to both sides. So this is log of 25 plus 1 equals x. And you could plug that in your calculator if you desired and get an answer, or you could leave it as its exact form and leave it like this. Question 2, natural log of 2x plus 3 equals 4. So in this case, I am given this in logarithm form. So in order to get rid of the logarithm, I'm going to use base to the logarithm. So my base here, remember ln natural log has a base of e, so this would be e to the ln 2x plus 3 equals e to the 4th, because whatever I do to one side, I got to do to the other. So these cancel and go away. This becomes 2x plus 3 equals e to the 4th. And then you solve it like you solve a normal equation. So subtract 3 from both sides. So 2x equals e to the 4th minus 3. Divide everything by 2. So you get x equals e to the 4th minus 3 over 2. And you leave your answer like that. So you would use a when you're given exponential form. In the problem, and you would use b when you're given the logarithmic form. So if the problem gives you a logarithm, you're going to use b to get rid of that logarithm. If you're given an exponent, you're going to use one like a to get into to get log base 10, or whatever log is going to work for your problem.